Hi guys, today we see about binomial expansion, which is also called binomial theorem. So binomial expansion means simply we expand a plus b term like a plus b is already expanded sometimes or most of the time. If you like to expand a plus b whole square, our formula becomes a square plus 2ab plus b square. And similarly, it's very frequently used formula as a plus b to the power 3 as a cube plus 3a squared b plus 3a b squared plus b cube. And so on. So if you like, then you can find expansion of a4 also. It's a bit hard work to find a plus b to the power 4, so but it's not impossible. You can find like this: a plus b whole square and a plus b whole square, expand both the thing, then it is a square plus 2ab plus b square, and then another term is also the same expansion, a square plus 2ab plus b square. Now further multiply these two terms, then we have a to the power 4. We are multiplying with a square first, so this is 2aqb plus a b square. Then we start with 2ab, then it will be 2aq b, and then 2 to the 4 a square b square, then plus 2 is here, is only once, and b square is bq. Now it's the turn of b square, it's the turn of now it goes with b square, then plus it is a square b square, so we are taking with b square, so it is 2ab square plus b square, and b is b cube, and then it is b square is b4. Finally we simplify it, so it is a4. Let's check 2aq term. Yes, we have two times of aq term, so we can write plus 2 to the 4, 2 plus 2 4 aqb plus now ab square. Let's see how many times it is ab square. You can't see ab square, but b1 is a square b, ab square, there must be another ab square, so 1 ab square, then lastly ab square b square a square, so a square b square, there should be another a square b square is here. Yes, but it's not that. This is also a square b square, this is a square and then b square, this is also a square b square. Yes, so it is 2a square b square. Now we are working with this a square and b square, so let's check again. It is a4 2aqb plus a square b square, alright, plus now 2aqb, then 2 to the 4 a square b square, then 2a b cube, 2a b cube, then it goes with b square, so it is a square b square, then 2a b cube, then b4. After that we have a4, aqb, aqb, we have aqb, aqb, how many times? 2, 2, 4 times. Then a square, b square, a square, b square, we have 6 times of a square, b square. Now 2abq, 2abq, we have 2 plus 2, 4a bq, all terms have been occupied. Now it is left with b4. And if you like, you can also expand a to the power 5, although it is a bit of more hard work, but it is possible. What if a plus b to the power 17? This is not wise to use, or this is just not wise to waste the time in expanding like this. So we can develop a general formula for the expansion called the binomial expansion. Why it is called binomial expansion is that because we have two terms a and b, and we are concerned to expand these two terms. Therefore the expansion of these two terms is called the binomial expansion. Hence the theorem developed is called the binomial theorem. So let's try with some permutation and combination concept. So here you can write a with, because power nothing here, that means the power is 1, and suppose this one as n. So NCR, we use NCR term. So here n is 1, c is 0, and c 0, and a to the power 1, b we don't have, so it is b to the power 0 here. Then 1 c1, a to the power 0 because a doesn't exist here, and then b to the power 1. If you compare both sides, although they look different, but they are the same thing, because 1 c naught value is 1 and b to the power 0 is also 1, all of you know, and then it is remained with a. And then 1 c1, if you press in calculator, it's again 1, and a to the power 0 because it doesn't exist here, and it is 1, and then b to the power 1 means b. So there is no difference in writing this and b. Let's try what happens here. If you try at this point, it's going to be, as n is 2 here, so NCR means 2 c naught, a to the power 2, b doesn't exist, so b to the power 0. Let's check it here. You can check in your calculator that here is nothing, means 1, that means 2 c naught is actually 1. If you press in calculator, a square is already there, b doesn't exist, so we could write b to the power 0 as there is 1. Now we always keep 2 as n, so 2 will be always repeating here. So 2 c1, a to the power 1, b to the power 1, a means a to the power 1, b means b to the power 1, 2 c1 means 2. You can check it in your calculator. If you put this value 2 c1, then you will get the value of 2. So instead of 2, we can write 2 c1. But why 2 c1? Because n we have taken as n, 2 we have taken as n, or vice versa. So a1 b1. Plus, in the same sense, we should not change this position of n, so it is 2 c2 because there is 1 and 2 c2 is 1. A doesn't exist, so we can write a to the power 0 because there is 1 always, and then b squared is already there. What if you apply here? Here it is, in place of n, this is 3. So what I write here is 3 c naught because there is 1 and this is 1, and then a to the power 3, and then b doesn't exist, b to the power 0. Here we can write 3 c1 as 3, and 3 c1 are the same value, so it is a squared b to the power 1 plus 3 c2 again is 3, you can check it, then a to the power 1 and b squared, and then finally 3 c naught in place of 1, 3 c naught in place of 1, and a doesn't exist here, but there is 1, so we can write a to the power 0, and bq is already here. Have you seen something? Means, look at here, the power of 3, it's in the decreasing order, that is in the descending order. At the same time, the power of b is increasing. That is the one feature. Another feature, You can see in 3c naught here, then b to the power 0. Here 3c1, then b to the power 1. Here 3c2, then b to the power 2. And sorry, 3c3. There should be 3c3. So if there is 3, then b to the power 3. Similarly, you can write here 4c naught a to the power 4 b0 plus 4c1 a cube b plus 4c2, because 4c2 is 6, so you can write this is a square b square, and this is 4c3 is 4 itself, you can check it in calculator, and this is 1, and this is b cube, and finally it is 4c4 a to the power 0 and b to the power 4. Now without expanding like this, can you imagine to write expansion for a plus b to the power 5? Let's check. So here first place is 5c naught a to the power 5 and then b to the power 0 plus 5 c1 a to the power 4, b has 1 power, 5 c2 a to the power 3 and b to the power 2. So always when you add these two, that should make n, that is 5 here in this case. Then 5 c3 a to the power 2 b to the power 3 plus 5 c4 a to the power 1 b to the power 4, and finally 5 c5 a to the power 0 and b to the power 4. Similarly, if you like, you can write for this also. So let's rewrite this thing. So we should eliminate the extra term. 5c naught, it is 1, and this is also 1, so we keep a to the power 5, and remaining term we like as it is. It is 5c1 a4 b plus 5c2 a cube b square plus 5c3 a square b cube plus 5c4 a b4 plus 5c5 is 1, a to the power 0 is 1, so finally we write b to the power 5. Okay, so here it would be 5c5. Yes. So what if we generalize this? For example, let's take a plus b to the power n equals to, you can see this is n is 5, then it is a to the power 5, so we can write a to the power n, then 5c1 means here in place of 5 is n, so we can write nc1 a to the power 4 means it is power 5 in other step 1 less than 5. So if the power is n, then 1 less than n is n minus 1 and then b. Then we can write nc2 a cube means again it has gone down by 1, so minus 1 power and another minus 1 is a to the power n minus 2, and b has raised power 2. And if you would like to write third term, so it is nc3 a to the power n minus 2 or 3 n minus 3 and b to the power 3. So always these two are equal. When you add these two, this is the total power in the binomial bracket, and so on it, and finally you can see it is b to the power 5, so here b to the power n. So what kind of benefit you get it by? So it's clear, almost clear, that you can see the difficulty level. If power is 1, you don't need to expand it, but still there is some expanded form once you open the bracket. A plus b whole square, we have 3 terms. Also you note that if the power is 1, there is 2 terms. If power is 2, there is 3 terms. And power is 3, let's check how many terms are there. 1, 2, 3, 4. Power is 4, then how many terms we have? 1, 2, 3, 4, 5. So 4, then plus 1 term more. and then power 5, there must be 6 terms altogether. So 1 2 3 4 5 6, and this way. So n, we don't know how much it is, so it depends on the value of n. If the power is 5, there is 6 terms. If power is 500, then there is 501 terms in the expansion. Okay, so this is the kind of thing. Now you can also go further to this term in the expansion. Note that this is one formula for the binomial expansion. Let's check now. If you break this, if you break this combination, then let's see what happens. Like here it is done for you, but once again let's check. You know that NCR equals to n factorial by r factorial n minus r factorial. So here NC1 is going to be n factorial by 1 factorial n minus 1 factorial, and then if you further expand, like it is n minus 1 factorial, you drop it here because in the denominator there is 1 minus n will go cancel. So this is n by 1 factorial. So you can write in place of, it is a to the power n, plus in place of nc1 you can write n by 1 factorial, and then a to the power n minus 1 and b. What about nc2? If you see nc2, then that is going to be n factorial by 2 factorial n minus 2 factorial, and then we have to expand n and n minus 1, and we drop it n minus 2 factorial, as n minus 2 factorial is in the denominator, will be cancelled out. So these two are cancelled out now. So we have n by n minus 1 factorial, no factorial, so it is 2 factorial. So in place of nc2 you can write n minus 1 by 2 factorial, and let's see what is there. It is a to the power n minus 2, then b square. Now in this case you don't need to break it, you can find by induction. So let's see here, n by 1 factorial and n minus 1 by 2 factorial. So for this term is going to be n minus 1 and n minus 2 divided by 3 factorial, and the terms are there, a n minus 3 and bq. Okay, plus so on plus b to the power n. If you like to consider another term, it will be like n minus 1, n minus 2, and one more n minus 3 by factorial 4. So this is all about this is not all actually, but this is about how to develop a formula for binomial expansion.